Okay, so here I am. If you did it, you will be able to see this screen, and there are lots of things that you can do on SAS Viya, and it's really impressive. I am impressed by the capability of SAS Viya, and I strongly encourage you to learn and get certifications, and if possible, go into this analytics area. Just Angelo just told me that a student from James Madison University, he gets paid $35 per hour for his internship. Now, it's a real job. It's an internship, but he gets paid $35. So there's a real prospect out there, and I encourage to explore the possibility. So here is the modeling tools that you can do. Here's manage model, build model reports, prepare data, project recent. And these are all very impressive things that you can do. And something that I want to do is, first, I want to teach you this hamburger icon on the top left. You see hamburger icon here. If you click on it, you have models such as manage data, prepare data, explore and visualize, and so forth. So here in the SAS Viya, it's running on cloud completely, and you can manage your data and prepare data. This task of data cleaning and data provisioning can be done on SAS Viya as well, just like Tableau. And today, what I like to do is I want to go to explore and visualize the data, right? So explore and visualize data. I chose this hamburger icon, and then chose explore and visualize. And we will build models later next week. We're going to learn that. And today, just explore and visualize. The first thing that we want to do is we want to start with data, right? So first of all, we want to start with data. So click on Start with Data. Click on it. Start with data. And here, there are a lot of data that you can use, pre-saved data, available data for you. And the data that I want to work with is BS. Just type BS. Oops. So BS, and then you see BS underscore and bank. So this one, the first one that comes up on the line, that's the data that I want to use. And if you click on that, it says this is BS Bank, and how many rows? 1.1 million rows. So it's a large data set, right? 1.1 million data. And however, SAS Viya can handle this large data, big data, pretty quickly. And we have 56 columns. What does that mean? 56 columns in Excel, 56 columns, 56 variables you have, and you can run it here in this data set. And here are the things that you can see. So 56 columns, and what are they? First one is B target. Second one is category input 1, category input 2, CNT target, demographic age, and so forth, home value, and so forth. You have a lot of variables you have. And that's what it is. And okay, I know that, and click on OK. Then you are going to load the data, right? You're loading the data, and here we go. So here you can explore and visualize your data on this pane. Are you with me? Okay, good. Now, if you have done that, let's look at the data. So on your left pane, you see data, object, suggest, and outline. And you're going to be using data icon when you are looking at the variables, what you have in this data set, what kind of analysis you want to run. Those things can be done in this data set. And second one is object, is what kind of models are you going to use? Are you going to run linear regression model, general linear model, generalized linear model, forecasting, machine learning, decision model, cluster model, all those things can be run there. So let's click on data first, and you see all these 56 columns over here. So the data that you have is available right here. So we see two categories, just like Tableau. We had measure variable and categorical variable there. Likewise, we have dimensions or category, and we have measure variables, right? Very similar to Tableau. And we have measure variable. What does it mean by measure variable? Measure variable is continuous variable, just like GPA, that ranges from 0 to 4, something like that. That's a measure variable. Categorical variables are like sophomore, freshman, and the junior and seniors. Those categorical variables are available right here, right? And I want to understand what kind of this data is. So let's take a one break, and let's go back to course canvas and scroll down, and you'll see the second line that you have is BA01 VS Bank data information, right? VS Bank data information. So this is the data. And because, I don't want you to just explore data without knowing what it is. So what is this VS Bank data? So if you look at here, this is a large data set with more than 1 million rows and 24 columns, or actually 56 columns. Primary focus is the binary target. And binary target is whether you are going to be able to sell a product to a customer or not. And this is financial industry, right? For example, sell insurance or sell stock, right? Sell a checking account, right? That's a financial product. And are you able to sell it or not? That's binary target data. Observations from a large financial services firm's accounts in the data represent consumers of home equity lines of credit, automobile loans, and other types of short-term to medium-term credit instruments. A campaign interval duration of the bank is half of a year. So campaign happens twice a year. Campaign is used here to denote all marketing efforts that provide information about and motivate the contracting of the bank's financial services products. Further, campaign promotions are categorized into direct or indirect campaigns. And here are important information. You have to know what these variables are. Later, I'm going to give you homework, and I found that some people do not understand what the data is about. As a result, their interpretation is completely off because they don't know what this data is about. So a binary target is, again, account coded with a 1 contract for at least 1 product in the previous campaign season. And a target interval new sales is the amount of financial service products per account in the previous campaign season. Third one is CNT target, the target count number, new products, the number of the financial service products per account in the previous campaign season. That's 3 binary target variables, which we'll be using as a response variable or dependent variable. Now, we have categorical variable here. Categorical account level 1, X means high activity, Y means average activity, Z means low activity. So you categorized 3 people into 3 categories. People into 3 categories, X, Y, Z, high, average, low activity. And category 2 is customer value level. 5 level, A to E levels are available. And the most profitable credit-worthy customers are coded with an A. E means not as profitable, not as reliable customer. So A to E is there. Now we also have this RFM to 10. I want you to understand RFM to 12 actually. RFM 1 to 12. RFM 1 means average sales past 3 years. RFM 2 is average sales lifetime. RFM 3 is average sales past 3 years. And RFM 4 is last product purchase amount, and so forth. So what kind of things they have done will be available right here, and you can use this one to explore data. Let's go back to SAS. So I'm here, back to SAS. And I want to know what those variables are. So go to data. And I'm going to bring up RFM variables. So let's go to RFM1. So let's bring it over to the report. I dragged it to the report, to the pane, to the white space, right? So do you want me to do it again? So go to data and RFM1, average sales past 3 years. Click, drag it over to the pane, and it's going to visualize it right away, right? You know, you don't have to do anything. Tableau, you have to, it's just like Tableau, you know, you drag it over, but the SAS is more advanced than Tableau and shows everything to you. And it says frequency of RFN1, average sales past 3 years. What is the average sales? And what we see is that this is skewed to the right, right? Skewed to the right. If you have frequency over here, oh yeah, thank you. So skewed right, this is skewed right. So mode, the frequency is coming up here, and then it's just going down and down to the right, and this is skewed to the right. If you have a different one, say skewed to the left, and this is skewed to the left. Right? And this sales data is skewed to the right. What does that mean? Can anybody tell me why this data is skewed to the right? Angelo. Average sales. So the average sales, the amount of the sales is less than like $100. You know what I mean? So $1,000 right here. If you hover over there, that's $50, $75. So average sales was less than $100. So a lot of small transactions with so many customers. And the frequency is more than 800,000 people or 900,000 people. So lots of small transactions with so many customers. That's what have this bank been doing. However, occasionally there are cases where you have done a large transaction, right? So that's shown right here too. So that's why it is skewed to the right. And in statistics, it's not good for you to have skewed data. You always look for normalized data, normal distribution. That's a key. So therefore, we know that this one has to be transformed, log transformation, as I said before, right? So let's do transformation, log transformation. And as I said, if you use log, what happens? Right? We have 1, 10, 100, 1,000, 10,000, 100,000, 1 million, right? If you take log transformation, I said log 1 equals 0. Log 10 equals 1. So it corresponds number of zeros. And log 100 is 2. Log 1,000 is 3. Log 1 million is 6, right? So you change this large value to smaller value. That's log transformation. And let's try log transformation together. So let's go to data. And then you can say new data item here, new data item. And then I want to calculate item. So calculate item here. And you can say RFM1 log transformation. Right? So RFM1 underscore log transformation. That's what I wrote. And then I'm going to go to operators. So we have data item tab and operators tab, and click on operators tab. And then you have various options, numeric, comparison, Boolean, and numeric advanced, and so forth. I'm going to go to numeric advanced transformation, and then I'm going to be using log. So click on log and bring it over to the right pane, and it says number, log, and number. And left box is for the variable that you're going to be transforming. So click on that. Go to data items again. Oh. So let's replace with, so click on number on the left box, right click, replace with RFM1, go to RFM1. Right here, average sales past 3 years data, click on that. Then you replaced the left box with RFM1, average sales past 3 years data, right? And then the log that you are going to be using here is it's a natural log, which is 10. So I'm going to just put or insert 10 on the right box. And that will help you to do log transformation. And if you have done that, click on OK. And you will see RFM1 log transformation, newly created variable for your analysis. I'm going to create a new page and go to data and drag RFM1 log transformation and see what happened. So you did log transformation, and what do you see? You see, it's now more like normal distribution.
I followed your steps, but it didn't make a second page.
Okay. So it was plus log transformation. So let me do log transformation again.
I think I get.
So go here, click on data, new data item, and calculated item, and then go to operators and numeric advanced and log, drag it to the right pane. And then this number on your left box, right click, replace with RFM1 right here. And number is natural log, which is 10. And click on OK. That will create, oh, you have to give the name. So I gave RFM1 and then underscore transformed. Log transform, I said log transformation. You should get 2 of them. So let's do it again. So let me do it again. New data item, calculator item, operators, and you click on numeric advanced, and then log, L-O-G. And then drag it over to your right. Then you will get 2 boxes like that. Good. Angela, good?
What did you put for the title? The name?
I said RFM1 underscore log transformation. That's what I did.
Okay. Got it.
Okay, now let's go back to page number 2 where you have, so let me do this again. New page, data, and I'm going to bring RFM1, the one that was not transformed yet. RFM1 average sales past 3-year data right here. And we have this one. Go back to data again, and now bring up RFM1 log transformation and bring it up to the side by side on the right side. Yeah. What happened? Okay. Yeah, so you can display them side by side like this. You see the difference, right? So untransformed variable is very skewed to the right. However, the transformed one is skewed to, I mean, it's almost normally distributed, which is very good for statistical analysis. And actually, you have to do this log transformation for all the variables, RFM1 to RFM12. But thankfully, this data set actually comes with log transformation. If you look at logi underscore RFM1 to 12, they are already transformed into log. So you don't have to do it, but I encourage you to do it yourself so that you are familiar with log transformation. Another thing that I want you to look at, please open a new page, is the target data. So binary target data, let's find out. Here, target binary new product. So at the end of the list, you see target binary new product. This is the one that we are going to be working with. And I want you to bring up here and see how it looks like. So we have 0 and 1, and the majority of them did not buy the new product, which is 848,000 people did not buy your your product. Only 211,000 people bought the product. So that's what we see. And this is the response variable that we are going to be using. But notice that this one is on the measure variable, right? On the measure category. And I need to copy this variable and change it to categorical variable for us to use. So here, downward arrow, and then, oh, not downward arrow. You have to right click. Oops. What happened? So let's go there. So if you click on, if you made a mistake like me, they are selected. If you want to unselect, click on this icon on the left, measure icon, and only select target binary new product and right click. And then you have a menu called duplicate. So it will duplicate this variable for you. So click on it. That will duplicate your variable. And then I want to change this one to categorical variable. So click on these downward arrows. And then now the name is available here. And I'm going to change that. I'm going to say new. Okay. So target binary new product new. And then from measure to category, right? So this is categorical variable, change it to category. And at the moment you do that, what happens is that now it went under a categorical variable, right? So you have categorical variable. And let's display it again. Let's see what happened. On a new page, I displayed. Now it is understanding the variable as category. Before it was understood as a measure variable. Now it's understood as categorical variable. 0 and 1, you see, right? So that's good. Very good. Now let's also explore the data together. So open a new page like I did. Now I am on a new page and click on data. And I'm going to select large RFM1. So that's a log transformation. and then go to the end of that. So large RFM9. So, and then in the shift, okay, press shift and select all of them together. Hit, click on it. Then you're gonna select a large one, RFM1 to RFM12. All of them are selected, and drag it over to your pane. And it is going to create a correlation table automatically.
Which ones did you select again? Log RFM1.
Yeah, 1 to 9. Yeah.
You click on it, hit shift.
So let me, so large RFM1, and then go to the end of that, which is large RFM9. I'm gonna hold down shift, hold down, okay, and then click on RFM9. Then it will select the whole list, and then drag it to the page. And then, wow, right? So SAS understands what I want to do and gave me a correlation table. And the darker it is, the stronger correlation it has, right? So we see that large RFM1 has strong correlation with average sales lifetime and past 3 years direct promotion, and RFM4 last product purchase. They have very strong correlation with them. So the correlation is about 0.69, 0.71, 0.68, right? Those things you can see. Those are very strong correlation actually. And similarly, you can see RFM2 has strong correlation with RFM11 and RFM9 and so forth. You can see it right here, right? If you like to change the graph to a different one, you can do it. You can easily do that. So right here in this page, on the top right, you have 3 dots like snowman, and click on that. Then it brings up a new main menu, a list of new menu where you can change things around. For example, you can delete this page, duplicate this page, duplicate as, cross tab and heat map or any other graph that you can do. And you can also do change correlation matrix to something else that can be done. And let us use duplicate as bar chart. Those things again to repeat what we have done. So let's try large RFM 1 to 9 and bring it up here. And I'm going to change it to box plot. Change the correlation matrix to box plot and see what happens. Okay, so it shows the box plot shows the minimum, the maximum, and the average, and 25% quartiles. That's a box plot, and you can see it right away by using this visualization. If you like to try a different one, you can do so. Why don't you try and let me know which looks cool. For example, it could be scatter plot, or it could be bubble plot, or it could be even, this decision tree. So you can try a different one and see what works best. I did automated analysis, automated explanation, and it is trying to explain the data itself. The AI is running the data analysis and coming up with its own idea about the analysis. So artificial intelligence is doing that. What factors are most related to large RFM average sales? So it's cool, isn't it? What are the characteristics of large RFM1 average sales past 3 years? And the range and the frequency are analyzed. And this one, what factors are most related to large RFM1? And we find RFM1 and then RFM4 and RFM3 are related to each other. those analyses are done automatically for you. So it is cool. Did you guys find any other interesting topic? Visualization. If not, let's run logistics regression now. Okay, logistics regression. I want to run logistics regression. Let's open a new page. Here's the new page. And I want to now do this data analysis. Logistics regression. Which one is affecting new product sales the most that I want to look at? I'm going to go to object now. I'm now getting out of data, going to object. And then I'm going to scroll down all the way down. And I'm looking on linear regression, logistics regression. That's what I am looking at. Non-parametric logistics regression, that's a non-linear model. And generalized linear model is right here. When your data is not meeting the linear regression assumptions, then you're going to be using generalized linear model. Now I'm going to be looking at logistics regression. The reason why I'm using logistics regression, so bring it over to your pane. So it says assign data, right? Now I'm going to go to roles. On your right, again, look at here, roles, right? Here you're going to assign your variables. And response variable is the one that we have just created, which is target binary new product. Click on that. So that's our response variable. And continuous effects are the logic RFM 1 to 12. So that's what we want to look at. So it's hard to scroll down. What you can do is just type logic in the filter. Then all the variables that contain logic, the log transformation is going to show up. And I'm going to choose all of them, right? And then press Shift, and then hit. We'll select the last one. Then I am able to select all of the variables, right? I select all the variables and then click on OK, and that will select all these continuous effects for you. And you're done. So, and then click on this collapse side panel, and you can expand your pane and see what's happening with your data. So here's the result, and I'm going to name it as logistics regression. So rename it, right click, rename page, logistics regression. Okay, so this is, God bless you. And here is the result. Here is the result, and you should, you can create any result. The thing is that you want to interpret this result. And the interpretation matters. And look at here, fit summary and KS Uden and so forth. And the first thing that I want you to look at is R squared, right? Whether this regression is making sense of the data or not, right? So click on KS Uden and change it to R squared. Almost at the bottom is R squared. And it's 0.2097. It's not great, but it's pretty good in business research. 0.20 is not great, but it's pretty good. That's what I can say. So so what does that mean? 20.97% of the data was explained by these independent variables, RFM1 to RFM12. That's what it means. So let's write it down. You got to know how to interpret it. So I'm going to write it down. How should I write it down? So I'm going to write here R square 0.2097. It means that 20.97% of the response variable, which is target new product, is explained by the 12 independent variables, or you say predictors. Okay, so the variance of 20% of 90% of the response variable was explained by these 12 independent variables, namely RFM1 to RFM12, right? So RFM1 to 12 explained 20% of target new product. And notice that RFM1 to 12 is sales data, promotion data, direct marketing, and those data or those efforts are included in this RFM1 to 12. And by the way, this is real data. This is real data. It's not something that they made it up, but they have real data, and 20% of the sales is related to these independent variables. Does it make sense? So that's good. And what's next? What indicators do you need to look at? If you confirm that R square is pretty good, then what should you do? What is the next thing for you to do? Anyone? Look at here. What did I do? If the model is good, then what did I say? You need to look at the strength of the relationship, right? The strength of the relationship was explained by what? By coefficient. How strong coefficient you have, right? If it is standardized, that's what you want to look at. So go back here and look at this graph. Bit summary. Bit summary says that this one has p-value 0.00001. What does that mean? This is statistically significant, especially RFM2 is statistically significant. Look at this one, RFM4. It is statistically not significant because the p-value is 0.44. So here's the golden rule of statistics. The golden rule of statistics. If p-value is less than or equal to 0.05, the result is statistically significant. Okay, this is a golden rule of statistics. You've got to know what this means. Okay. P-value is less than or equal to 0.05. And it means that the variable is statistically significant, right? So you have college degree, experience, and networking and personality as a function of the great jobs. Then you have to look at whether this p-value of college degree and so forth is less than 0.05 or not, that you have to look at. And thankfully, SAS is producing the result for you so that you can just look at it and interpret it. And you'll find that RFM 1, 2, 5, 9, 3, 12, 6, 11, 10, 8, 7 are significant. Their p-value is less than 0.00001, which is really good. The next one, 0.0273. So what does that mean? Is it significant or not? p-value is 0.027. What does that mean? Is it significant or non-significant? So raise your hand if it is significant. Everyone has to raise your hand, okay? Significant, raise your hand. Not significant, raise your hands. The answer is significant because p-value is less than 0.05, right? What did I say? I said if p-value is less than or equal to 0.05, then it is significant. That's what I said, right? That's the golden rule of statistics. So, and that's done. So this one is significant. It's in purple. But now the last one, RFM4, is not significant because it's 44%. So therefore, this is not significant. Got it? Yep, very good. Now, I want you to download this result. You can download this result. Go to this 3 dots or snowman there. And it has export data. You see? Export data. Click on it. And formatted data Excel file. You can choose, I think, Excel file only. Click on OK. And it's going to download the data. And I have logistics regression, target binary, new product, new one. Downloaded it. And where is it? Here we go. Do you have the data? So you see model information, what model was ran, and dimensions, what dimensions is used, response profile, iteration history, convergence, fit statistics, including R square. I'm going to just highlight R square here. Now, parameter estimate. This is the important one. Okay, so this is the one that I am looking for. And look at P statistics, 0.27. This one is not significant, but the rest is significant. Okay, so these are significant stat. And now I'm going to write the function here, okay? So here, target new product binary equals, right? Equals. So if you just do it manually, this is what you're going to be doing. 6.79. Okay, I'm going to just write it down. That's an intercept plus 0.03 RFM1. We say average sales 3 years. Right, that's the first variable. So here, 0.03 is the coefficient, and RFM1, average sales past 3 years. That's the name of the variable. So that's the first one. Second one is negative, is not plus actually, negative 0.13. And the variable is RFM10, count total promos past year. Very interesting data. And then negative 0.18 times count direct promos past year. And I'm going to just abbreviate it, and plus 0.19 RFM 12 minus 1.23 average sales lifetime, RFM2, plus, actually it's minus 0.28 RFM3, and then again negative 0.006 RFM4. It's we have 12 variables, so it's long. And plus 1.70 RFM5 minus 0.23 RFM6 minus 0.07 RFM7 plus 0.09 RFM8 minus 2.27 RFM9. Whew. That's it. This is the equation that we found. We have found the coefficients, the relationship, the strength of the relationship between this target variable and the independent variable, right? This is it. And I want you to notice that there are not only positive, but also negative variables. So first of all, I find that this is the strongest. The coefficient is the strongest, negative 2.27. It's not positive, but it's negative. What does that mean? If it's a month since last purchase, so if can anybody interpret this coefficient? What does that mean by negative 2.27? So first of all, I want you to notice the sign. It's negative, not it's positive, right? So that means the more sales you made last month, okay, the more negative new sales you are going to make. Does it make sense? So last month, I bought a new product from this bank, say checking account or stock portfolio, something like that. And this month, am I gonna buy it or not? It's likely I'm not gonna be buying, right? It's a negative impact. I'm not gonna be buying it. If it's positive, for example, here you have 1.7. Look at here. So let me give a different color. 1.7, count purchase past 3 years. So if you have purchased a product from that bank last 3 years, then I am likely to buy another product from this bank. 1.7 positive impact. However, if I bought it last month, I'm not gonna buy it. There's a negative chance. Does it make sense to you? So look at here. Say this is positive. The more college degrees I have, the more chance for me to get great jobs. Okay? However, say I have negative. The more experience I have, the less chance for me to get a good job because it's negative. Does it make sense? That's what it is here. So here, positive means the more purchases I have made the last 3 years, the more likely that I'm going to buy this new product. However, if I bought it last month, that means I'm not going to buy. It's a negative impact. So if somebody bought last month, it's better not to ask. Say you bought your car last month. Are you going to buy a new one this month? No, I bought insurance, life insurance last month. Am I going to be buying again this month? No, I'm not going to buy it. That's what it is here, right? I bought that product from this bank. I opened a new account with this bank last month. Am I going to open again with this month? No, I'm not going to do that. Right? So there's a significant negative impact, very, very powerful negative impact if you did a transaction. What? Are you singing for me or what? Does it make sense? You got to understand positive and negative. So that's the first thing. Is it positive or negative? That's the first thing that you want to understand. Second of all, how strong is it? How strong impact does it have? That's the second thing that you want to understand. And we have run a special type of regression called logistics regression. And in this case, you have to use a function called exponentiated coefficient. So I'm going to write here exponentiated coefficient. Exponentiated coefficient. And what this does is that because you already used log function, I'm going to make it back to a normal value so that I can interpret the impact. So I'm going to use exponentiate that value. So exp parenthesis, and then open this estimate and close the parenthesis so that I can interpret this coefficient as they are. So click on OK, and then drag it down, copy it, and you have all the result. And maybe I can, God bless you. So I have 1.03, 0.87, 1.22, 5.52, 1.10, 1.10. Notice that there's no negative. Do you see that? There's no negative. And this is because it's a logistics regression. And I'm going to be interpreting it right here. So it means, for example, RFM1. And the exponential coefficient is 1.03. Okay. And here I'm going to say this one minus 1.03. Interpretation. Okay. 3% of chance one unit of increase in average sales past 3 years will increase new product sales by 3%. Okay, this is what it means. 1 unit of increase in average sales past 3 years will increase new product sales by 3%. So, and if you know the unit, actually it's $1, right? $1 increase in average sales past 3 years will increase new product sales by 3%. That's what it means. You got to write this down so that you can interpret it later, okay? I'm going to just take 3 examples and then leave the rest to you. That's RFM1, RFM10, RFM10. That's 0.87. So this is exponentiated coefficient and percentage interpretation. variable. That's 0.87. And if you look at it, 1 minus 0.87 means 0.13. Oh, I'm sorry. Minus 1 is negative 0.13. And this one means one count increase in total promos past year will decrease new product sales by 13%. Okay, so negative 1.3. Therefore, one count increase in total promos past year will decrease new product sales by 13%. Wow, that's counterintuitive, right? You thought that if you increase your promos last year, that would increase your new product sales. That's what you thought. But here is a negative consequence of running promos last year. It has negative impact. Carlos, doesn't it make sense to you? Right? So negative impact right here. It's counterintuitive and very insightful. And let me do it once more, RFM 11. And exponentiated coefficient is 0.83. And if you do this one minus 1 is 0.17. And RFM 11 is count direct promos past year. One count increase in direct promos past year will decrease new product sales by 17%. And I want you to work on RFM 12 to 9, okay? RFM 12 to 9, write down your own interpretation. And I'm gonna walk around and to see what you guys are doing.